In this video, we are going to do 14.02 word-length. Alright, so I have the file downloaded and open racket. So let's just go over it. Let's look for problem A, the problem statement. So notice that the data design steps are done above, right? So all these are checked off. Let's just review them. So list of string is one of. Empty or cons string, list of string. We're dealing with self-reference. The interpretation is that it's a list of strings. And here is the template for that. Data examples are omitted because we're going to write them alongside with the tests. Alright, so design the function word-length, which produces a list of string where each string is postfixed with dash and then this length. Alright, so they give us an example. So word-length of cons hello, cons meow empty produces the list of strings, but with a dash and then how long the string is, right? So in this case, hello is 5 characters long. So it's -5, right? Meow is 1, 2, 3, 4 characters long. So we, add a -4. All right. Finish the uncompleted function design steps 1 through 5 above, like so, for the design of word-length. All right. So pause the video and try to work through it on your own. I'm going to go with spoilers in 3, 2, and 1. Alright, so it must seem that you guys took a good swing at it, so now let's go over it together. As always, we start off with the signature. So word-length consumes a list of strings and produces a list of strings. Alright, next is the purpose. So produces the given list of strings where each string has dash length appended. Let me just quote that correctly. Appended. Alright. Next is the stub. So define word-length of the list of strings. We'll call it string list to follow the template above. Alright. And this has to produce a list at the end of the day, right? A list of strings. So let's just use empty as a dummy value. Alright. Let's run some examples on this. So word-length of the empty list, all right, should produce empty. We still have to produce a list at the end of the day according to the signature. So a list of strings and empty is in this category. So let's just do that. Just another example. So check this back to word-length. All right, let's do wolf. All right, of the list cons wolf on the empty. My bad. What should this produce? Well, it should produce cons wolf -4, right? Because wolf is 4 characters. And we had to append dash and then the length of the string, all right? Empty, like so. Let's do the to-length case. To-length long list case. They give us this example, so let's just copy and paste it down. Like so. So cons hello meow produces cons -5. Cons hello -5. And then cons meow -4. All right, so let's run our stub against these examples to make sure there are no typos. And this just differs and mismatches. We are good in this department. Going to comment out the stub here. All right, let's look for something that consumes a list of strings. That's a template that we can use as a scaffold. Like so. Rename this word-length. Okay, so now really pause the video. Hopefully this should be all the mental scaffolding needed to write the function word-length. I'm going to go with spoilers in 3, 2, and 1. Alright, I'm assuming that you guys took a good swing at it, so now let's go over it together. So looking at our examples over here for the base case, right? If we consume an empty list, we should just produce empty, right? So like so. Alright, now comes the harder part, alright? So we have to produce a list of strings. And the only way we know how to do that is with cons. So that's going to be the combinator. All right, so how do we transform, let's see this case, right? Wolf, right? So this is going to be a string wolf. What do we want to do to it? Well, we want to do operations on strings, right? So you would go into the documentation and look for operations on strings and see how you can transform wolf into wolf-4. In this case, I know what we need to do. We need to do a string append, right? We're going to add a dash here, like so. So this is going to be the string wolf. So we need to add a dash, and then we have to add the number, right? So we're going to have to take the string length of the first of the string. So I'm going to copy it, paste it, and then wrap it around string-length. And since this is splitting up into multiple lines, I'm just going to do that. All right, so that is the transformation of wolf into wolf-4. All right, and what do we want to cons it onto, right? This transform string. Well, we want to cons it onto what we assume is the call to word length. What we will assume will be word length fulfilling its purpose statement onto the rest of the list. All right, so it will work for a list of any length. All right, so let's just run this code and make sure it works. And we get some errors here. So string-append expects a string given 4. All right, so this one is another issue given 5. All right, so I know the bug here. So the problem is string-append takes in strings, right? So we did this, right? You have to turn this number 4 into the string 4, right? And how you would discover this is you would use the stepper if you didn't know offhand, off the top of your head. In this case, I'm really comfortable with the error messages and what they're telling me, so I know that we need to wrap this around number to string, number arrow string. All right, and I'm gonna space this down more because it's hard to see. Control I to re-indent that over there. All right, so now let's run it, and all 3 tests do pass, like so. All right, you're free to step through it and see how it works at a mechanical level, but let me just table it really quickly. All right, so we're going to do the most complicated test we have here. That's 2 long, cons, hello, and meow. You can make a 3 long list if you want, but nonetheless, for the sake of time, we start off with this list. Is this list empty? No, there's, cons, hello, and meow in this list, right? What's the first of this list? Well, it's going to be the string hello. All right. So Racket is going to do a string append of the first of the list. So that's the first of the list. We're going to put a dash there, and then we're going to count the string length, right, which is 4, like so. All right, and then the rest of this list is going to be cons meow empty, like so. And then we're going to do a recursive call on this, right, which is going to be the rest of this list. So we're going to do cons meow empty, right? We're in the recursive call of word length. Is this list empty? No, there's meow in this list. Likewise, the first of this list is meow this time. And this one would transform it, string meow, and then get the string length, which is 5, and put a dash 5, right? Postfix it like so. And then we take the rest of this list yet again for the final recursive call. So it calls itself again. All right, so now we're confronted with the empty list. Is the empty list empty? Yeah, there's nothing in this list now. All right, and this would be an error. And then, of course, error, error. All right, of course, the base case, right? We're gonna put base case empty. All right, and we found out that we needed to do cons as the combinator. Anywho, this is the bird's eye view of word-length. All right, I'm gonna submit this into the hand-in and make sure it passes the grader test. All right, and submit that, and I recommend you guys check your score on the website like so. Anywho, that is about it for this video, and I will catch you in the next one.